This time, I will introduce a pregnancy test using a frog. From the 1930s well into the 1960s, pregnancy testing required a slippery piece of equipment. A female African clawed frog. For decades, hospitals and research labs around the world had a trusted supply of these handy amphibians, employing their help in testing for pregnancy. And in numerous other scientific endeavors. So, what makes these phenomenal frogs so special? The remarkable features of the African clawed frog have fascinated researchers since the 19th century. We often think of frogs as hopping around to snatch up bugs with their lengthy tongues. But this water-dwelling species is almost exclusively aquatic, having adapted primarily for swimming rather than crawling or jumping. Weirder still, African clawed frogs have no tongues at all. Instead, they suck food directly into their mouths or use their hands to catch larger animals which they tear apart with powerful hind claws. To help get close to their prey, their smooth skin can quickly change color to blend into their surroundings. This camouflage ability was particularly interesting to a trio of biologists in South Africa during the 1920s. Hillel Shapiro, Harry Zwarenstein, and their teacher, Lancelot Hogben, were researching what role the pituitary gland, a small region of the frog's brain, might play in the color-changing mechanism. Removing the gland altogether impaired the frog's ability to camouflage. But when Hogben injected them with a pituitary extract derived from an ox, he found an even more surprising result: the frogs began laying eggs. Normally, African clawed frogs only release eggs when a male frog is nearby to fertilize them. But this ox hormone triggered their ovulation without the presence of a male. And this process gave the researchers an idea. They knew there was a chemical similarity between the ox hormone and a hormone found in the urine of pregnant people, a compound we know today as the chorionic gonadotropin hormone, or HCG. In pregnancy tests of the day, animals like mice and rabbits were injected with human urine as a way of testing for the presence of HCG. However, this required multiple days of injections, as well as killing and dissecting the animals to see whether the hormone was present. Because of these hurdles, the test was reserved for specific use cases, leaving most people waiting for visible signs to determine if they were pregnant. But these frogs changed everything. They responded to HCG in roughly 9 hours with no need for dissection. And since their large ovaries constantly generate eggs, they could participate in numerous tests over their 15 to 30-year lifespan. Better still, these frogs were abundant in their native habitat, making them easy to find, catch, and export. Before long, tens of thousands of African clawed frogs were being shipped to hospitals all over the world, making reliable pregnancy tests widely available for the first time. In the 1970s, the frogs would be superseded by chemical tests that detected HCG directly. But by then their widespread presence in laboratories had made African clawed frogs the star of numerous studies. Their rapid development and ability to produce eggs in any season made them invaluable models for developmental biology. African clawed frogs have even been part of biological studies aboard the Space Shuttle Endeavour. However, frogs can be slippery subjects. More than a few of these amphibians have escaped their laboratory enclosures, and in many places, their ferocious appetite allowed them to outcompete native amphibians. To make matters worse, they often carry a deadly fungus called chytrid, which can cause an infection that lethally disrupts the delicate functioning of amphibian skin. In the 20th century, this fungal infection has devastated amphibian populations around the globe, causing the extinction of multiple frog species. Because of all these concerns, the African clawed frog is now classified as an invasive species and illegal in many regions. So in the end, like other pregnancy tests, the use of these frogs in scientific research has had both positive and negative results.